Hello friends, from the unit number 4, that is the programmable logical control. From this unit the most important point, that is the ladder diagram, we discuss today. So ladder diagram, this figure shows the ladder diagram. So ladder logic is a programming language that is used to program a PLC. PLC is nothing but programmable logical control. So ladder diagram is nothing but the It is a graphical PLC programming language which accesses logical operations with symbolic notations. These are the symbolic notations using ladder diagram. So this ladder diagram represents the symbolic representations of any system. So important parameters required for the ladder diagrams are the NO and NC contacts. NO is nothing but the normally open contact. So this figure shows the normally open contact. If the corresponding memory bit is 1 or it is on, this instruction will allow rung continuously and output will be energized. Then this figure shows the normally closed contact. If the corresponding memory bit is 1 or it is on, this instruction will not allow rung continuously and output on its rung will be de-energized. Then this figure is the output energize. So use an OTE instruction in your ladder diagram to turn on a bit when rung conditions are evaluated as a true. The important point in the ladder diagram is the anatomy of the ladder diagram. So this figure shows the ladder diagram. So important points are there is a rail rung. So rail, that is the vertical lines of the ladder diagram, are called as rail. So there are two rails are there. Then horizontal lines of the ladder diagram, all the horizontal lines are called as rungs of the ladder diagram. These are the inputs such as push buttons are the inputs of the ladder diagram. Then turn on or off of the electric motors and another components are the outputs of the ladder diagram. In the ladder diagram, the vertical lines, that is the rails, so left rail represent the power rail, right rail represent, or vertical line in the right side represent the neutral rail. So horizontal line, as we know, the it is called as rung or step. It is labeled numerically from top to bottom, that is rung 1, rung 2, rung 3. So last rung is called as end rung, or that line is called as end rung line. So input, all the input devices are connected towards the left side of the rail, nearer to the rail, and output devices are connected towards the right side of the rail, near to the neutral rail. The most important point, that is the ladder diagram for different logic gates. As we know the different logic gates, so first logic gate, that is the AND gate. So this is the ladder diagram for the AND gate. A and B are the inputs, and that is the this one is the output. When we get the output as high, that is the 1 shows the high, 0 shows the low. When both the inputs are high, then output will be high. If any one input is 0 or low, the output will be low. So in this AND gate, we require the both input as a high input, then we get the high output. The next one is the OR gate. This is the ladder diagram for the OR gate. These A and B are, they are in the parallel connections. This one is in series connections. So we get the output, high output, for the three conditions. If one of the input is high, then output will be high. So if both the inputs are low, then output will be low. If one of the input, that is A or B, is high, the output will be high. The next gate is the NOT gate. This is the ladder diagram for the NOT gate. When input is low, output is high, and output is high, input is low, that is the 0. The next logic gate, that is the NAND gate. So this is the logic diagram for the ladder diagram for the NAND gate. NAND is a combination of AND or a NOT gate. The arrangement shows AND gate followed by the NOT gate. Hence it is called as NOT AND gate. If we see the table, then if both the inputs are high, then output will be low. If both the inputs are low or one of the input is low, then output will be high. The next logic gate is NOR gate. So this one is the ladder diagram for the NOR gate. NOR is a combination of OR and NOT gate. The arrangement shows, this arrangement shows OR gate is followed by NOT gate. Hence it is called as NOT OR gate. If we see the table, if both the inputs are low, then output will be high. If any one input is high, then output will be 0. Next logic gates are the exclusive OR gate. This one is the ladder diagram for the exclusive OR gate or XOR gate. If we see the table, then the output will be high if one input is low and another input is high. If both inputs are high, the output will be 0 or low. If both inputs are 0 or low, output will be low. If in the case of one input is high and one input is low, then the output will be high. The last logic gate is the exclusive NOR gate. So this one is the ladder diagram for the exclusive NOR gate. Here, if both inputs are low or if both inputs are high, then the output will be high. If one of the input is low or one of the input is high, then output will be 0.